Hey there, this is Philip from Eclipse Source. So what we do at Eclipse Source in our daily job is essentially supporting our customers in developing specialized IDEs, custom tools, domain-specific modeling environments in general. And of course, in the past 1 or 2 years, integrating AI capabilities in those tools has become a very important feature. So what I would like to do today is to introduce a few techniques and give you some practical insights on how you actually can integrate AI capabilities in such domain-specific tools, because that's what we've been asked quite a lot recently, so I wanted to share this in a video. While the insights and techniques that I will share are generic, I will show them based on a new framework that we've developed, which is open source and called Theia AI. And what Theia AI enables you to do is to integrate AI capabilities into Theia-based applications. Just in case you don't know Theia, Theia is an open source tool platform. So it allows you to develop modern web-based IDEs and tools that you can then either deploy as web applications or as Electron applications. Right, so let's start. What do I mean with AI integrations? So if you have spent a few minutes only on the internet in the software engineering bubble in the past months, I'm sure you've came across the projects like GitHub Copilot, Cursor IDE, Codium, or Project IDX, Cloud Dev, and all of these. They've become very popular. And what they basically provide is an AI integration in a way that they, for instance, automatically and intelligently autocomplete certain code. They have a context-aware chat window in your IDE that you can use to ask questions about your code or about general programming concepts. They maybe even go a little bit beyond and are more agentic in terms of that they suggest changes, suggest creating files, changing files and stuff like that, or give you some hints about how you create a certain terminal command and run it. And what these tools really provide and what makes them so special is that they go beyond just a tool integrated LLM chat window, right? So if you would have just a chat window that to talk to an LLM in your IDE, you would still yourself be responsible for defining your user intent by providing the prompt, specifying the context that is needed to perform the task that you're asking, the knowledge and so on. When you send that to the LLM and get back some response, you would then be responsible to manually transfer the response back into your project by, for instance, applying code changes in your editor, copying over snippets, performing actions and so on. So where the value is really added by all of these tools is that they are integrated seamlessly so that the user can essentially stay in their IDE and only specify their user intent, and the tool integration takes as much as possible over the task of creating the context, adding the knowledge that is maybe necessary, give some task instructions to the LLM in the background so that the LLM performs as much or as best as possible for the specific task. When it then returns the result, they will basically go the extra mile to make it as easy as possible to apply the suggestions for code changes or edits in your tool automatically, or even apply certain actions like creating files and stuff like that. So that's really where these tools provide extra value. So what they really want to do is to maximize the degree of automatic prompt composition and the degree of response actionability. And how they're doing that is essentially with these techniques. So they apply prompting strategies, context identification and augmentation, integrating tool functions so that the LLM can invoke certain actions in your IDE and so on. And we will discuss all of these and how these work and how you can integrate that in your tool. But now let's switch from IDEs to custom tools for a second. So what's special about custom tools? So when we are talking about custom tools, we mean tools like those that we see here, with diagram editors, with domain-specific languages, with maybe rather complex UIs and forms where there is an underlying domain-specific model behind. Of course, the advantages of integrating AI into such tools is as high or as beneficial as integrating it in the IDE, because you have the same use cases ranging from supporting the user in understanding certain concepts in the tools, helping them to fix errors, doing some editing suggestions, or even scaffolding entire artifacts for you. So just to give you an idea, I've prepared a small demo for a diagram editor to show you how such an AI integration could look like. So here we have just a diagram that depicts some sort of workflow. There is an underlying modeling language that defines syntax and semantics and stuff like that. And based on Theia AI, we have here now in our Theia application a chat window that I can use to, for instance, ask questions about this diagram. So for instance, if I ask how many tasks are executed in parallel, then it will basically give me as an answer, this is determined by the fork node, which has two outgoing edges to check WT and check TP. And that's exactly right? So basically what that means is that in this case, the AI had the context of knowing, there is one diagram being shown at the moment, so let me fetch the state of this diagram, and has then the additional knowledge to really answer questions about semantics about this diagram. And this is really what this whole AI integration is about. Of course, we can also then go one step further and, for instance, ask the AI to add two reasonable next nodes after brew. So let's see what the AI comes up with. So the AI added here pour coffee and serve customer. So it can even now interact with the diagram editor and trigger certain actions on top. Of course, it's now also a typical use case to integrate even more artifacts into answering questions. So for instance, if I ask the AI, no, I have the right one. What does TP and WT mean? Actually, this is not specified in this diagram as we can currently see, right? But the AI can still answer this. So it can, for instance, answer TP stands for temperature, and WT stands for checking weight, right? So where does it know it? And it knows it because it can also access additional documentation that is somewhere behind this diagram editor, and read it and incorporate it in its answers. And you can go even one step further with incorporating entire workflows where you say, actually, WT is not for water, it's actually for it's for water level. So let's please update the diagram as well as the documentation. And now basically you see it change the diagram to make it more clear, and suggested changes to the documentation where I can say, this is the right one, this is right, and done, save it and done. So this is just to give you a small example of how such AI integrations could look like. So what are the challenges in creating such LLM-based services in custom tools? So in comparison to general purpose IDEs, which are working with general purpose programming languages and plain text editors, of course, in domain-specific editors and models and languages, we have to deal with specific semantics, non-textual editors like forms, diagrams, and stuff like that, which also entail that we have to trigger higher level operations, not just adding plain text, but maybe connect to task nodes, creating new tasks of a certain type and stuff like that. And we need to add domain-specific knowledge on top, like, for instance, what is even an automated task and things like that. And of course, off-the-shelf LLMs often don't possess this knowledge. So there is a gap between the knowledge of the LLM and the one that is needed for the specific tool. So that means that the tool integration must carry even more weight than for typical IDE integrations. So let's have a look at how to implement such tool integrations. As I mentioned before, what I'm talking about is all these techniques are generic and can be applied everywhere, but I will demonstrate them based on a new framework that we've been developing together with the community in the Theia ecosystem, and that's called Theia AI. So Theia AI is a framework for integrating AI capabilities into custom tools, IDEs built with Theia. It's part of the Theia source code, so that means it's also open source, governed by a vendor-neutral open source foundation, and it provides reusable components, libraries, UIs that makes it very easy to integrate AI capabilities. And it is really designed to give adopters of Theia and Theia AI full control as with other aspects of Theia. You have full control where and how AI is integrated, which LLMs or services are used, whether it's a local LLM or some sort of hosted LLM in a that is accessed via some APIs, or so which tool data you want to share, which executed behaviors, and so on. So that's really all what Theia AI is about. So let's have a look at what Theia AI actually provides. So it has a chat window that it provides, and it has, that's really the center of it, agents, tool call handlers, and variable providers, and prompt management frameworks. And basically, these agents can then talk to LLMs that are provided by language model providers, and any other UI component in a Theia application can access, besides the chat, these agents to give some tasks to an LLM. So let's start with agents. What is a Theia AI agent? So the Theia AI agent is really the mediator between your tool and the LLM. So that means it encapsulates the prompting strategies, context augmentation, the LLM communication, tool actions, and all of that. In Theia AI, there are two types of agents. There are plain agents, which are essentially custom services that can be invoked from anywhere in the UI, or there are chat agents, which are agents that can be addressed in the chat UI. Before diving into how agents are implemented, just a very, very short primer on how to interact with an LLM in general, just in case you don't know that yet. So in a very simple term, the only thing that the LLM service usually needs to provide as a basic functionality is, given a set of messages, which can be tagged by roles. So for instance, there's a user message, there's an answer by an assistant, and then there is another user message, and this is all defined in terms of a system message, the whole communication. So based on these messages, you basically ask the LLM to complete the next message, and the next message is then typically, or always, with the role assistant, because that's what the AI assistant answered, and it would contain some sort of text. And this is really the basics. Of course, you have full control over what you provide here. So the assistant message here can or cannot be provided by the LLM. Maybe you have added that there, it doesn't matter. Essentially, you give it a set of messages and the LLM completes the next one. So what this all comes down to is essentially prompt engineering. Just in case you haven't heard about prompt engineering, basically that's it is essentially a technique to maximize an LLM's performance for a certain use case without modifying the LLM itself. So you basically take control over the prompt, what you send to the LLM, or the set of messages that you send to the LLM, and try to guide the LLM's output for a specific user input. And you do that by specifying constraints, giving instructions to fulfill certain goals, giving the LLM the information, the knowledge, and the context needed to get this goal done or to reach this goal, and directing the LLM to generate a specific and optimized response. So what that means is essentially when the user enters a message, you can have control over everything else that you put around it to guide the LLM to provide the type of answer that you're looking for the specific user input. And that's essentially prompt engineering in a nutshell. The most basic thing to start out with in terms of prompt engineering is to provide the system prompt. The system prompt is essentially sort of the first message that you send to the LLM that is not the user message. And in this system prompt, you essentially give all sorts of instructions to, for instance, adopt a persona, to reach a certain communication style. You can use in-context learning here by explaining the LLM certain concepts that are relevant in your tool. You can give it steps to achieve certain tasks, guardrail it to only answer about questions, answering questions in the context of this tool, and give hints about the communication format. And that's really what system prompting is all about. And you just add this on top of the user prompt. So just to show you how this would look like, in Theia AI, it's really easy to create an agent and just specify a system prompt. All you need to do is define this agent here by subclassing the default streaming parsing agent and specifying that the system message that you want to use is the one that we've just seen up here. And what you can reach with that is, let me just go back to the demo here. So when we, just starting a new chat here, when we ask an unprompted, without any system message, chat agent, what is the orange box? We can even say in my workflow. It probably, or for sure, won't be able to give you anything meaningful back because it has no idea what you're talking about, right? If I now take the chat agent that we just saw, that we've just seen before with the system prompt, and we ask it again, what is the orange box in my workflow? It suddenly can answer it, right? And that's not surprising because we've explained what types of nodes and edges are in our workflow and which color they have, what semantics they have. So we can even ask what other types of nodes can I use, and it will then tell you, there is an automated task, there is decision nodes, merge nodes, and stuff like that. So basically it now knows what all of that is about, and that's just achieved by a system prompt essentially. Of course, that's just the beginning. When talking about prompt engineering in general, then we also need to talk about context, because context is really key. What we mean by context is, for instance, adding not only just domain-specific knowledge, but also the state of the workspace, which files are in there, what may they contain, what is the current tool state, like which editors are open, what is the state of some documentation that is put somewhere, and so on. And this is truly important because with context we can answer questions like this: what is the initial task of the diagram? What is the diagram, right? So that's context, and that's what the tool integration needs to attach to the overall prompt, in addition to the instructions and the user input, to provide to get meaningful answers. And typically what that means is that you sort of define a context format, how you represent this format, and you then explain in the system prompt how this format works, and you can maybe use Markdown, JSON, XML, whatever works, and then augment your prompts with the context that is needed. And that's essentially also very easy to do in Theia AI. There is this concepts of variable providers, and with variable providers you can essentially specify variables that resolve to a certain contextual value that you can then attach. So if we go back to the demo, we can now ask here the same chat agent that we had before. What is the initial task of the current diagram? And it says, I don't have any information about the current diagram, right? Because where should it get this information from? But now we can give it this information by mentioning the variable, and now suddenly it gets context, it gets the current editors and what they include, and it can now say, okay, it's push. That's the first task actually in this diagram. Of course, this is super useful to give users the control to pull in context wherever they need it very efficiently, but very often, usually we don't want the user to having to add these variables manually, so we can also basically just include that in the system prompt or in some way automatically. So if I take just another example here, I will now use workflow 2, which is essentially the same chat agent as before, but it now always adds the diagram state, the diagram workflow variable, and now we don't need to add it manually, but still the agent is capable of answering the question correctly. So that's essentially the simplest way to add context to your prompts. However, as you may have guessed, there is an issue, right? So with a growing set and complexity of use cases, this also means that we have expanding range of different contexts and increasing volume of context. And we really want to avoid overfilling the context window of LLMs, not only because it may increase cost a little bit, but mostly because it will degrade the quality of the answer if the context that we provide is not relevant to the actual user input. So what we really need is very often a dynamic way of selecting relevant context based on the user request. And of course, the most important or most popular technique that is used for this task is Retrieval-Augmented Generation, or RAG for short. And essentially the basic principle or the idea in general is that instead of taking the query and giving it directly to the LLM and then receive the response, we first go to some sort of component to give it the query and resolve relevant facts or knowledge or data in addition based on that prompt, attach it to the query and send that to the LLM so that the LLM can answer the query based on the additional context that we've collected from this component, and is therefore much more relevant and much more precise. And there is very different flavors of implementing this technique. From them, probably for document use cases, similarity search is probably the most popular, but in AIs very often multi-term prompting is the strategy that is used very often, or even more agentic approaches where the LLM can decide itself which of the contexts it should obtain. Basically, what we have in addition, or why multi-term prompting is very popular in AI tool integrations is because very often we have very much different sources of context. So for instance, there could be documentation about a framework, about a tool or whatever. There can be the tool state that is relevant. There can be the workspace that is relevant. And that really depends on the user request, right? Which of those are relevant. So what we here often do is that we have some sort of classification step in the beginning. So before going to the LLM with the actual prompt, we first ask the LLM to classify the user request and identify which context might be relevant, and then based on that relevant route to the respective, based on the result, route to the respective context retrieval strategy. Then do what we discussed before, obtain the context, augment the prompt, and send this to the LLM. And how this could look like is here a simple prompt where we ask the LLM classify a user request targeted at an AI assistant for workflow diagrams to determine if answering the user request necessitates providing the AI with the current diagram, some documentation, or code that might be related. And we wanted to answer it in a specific output format so that we can very easily process it and we give it as a context the conversation. And that's really what then the LLM gets, and it will then answer, we should add the diagram, or we should add the code, or we have some other question that I can't really classify with the given categories. So this can be very, very easily implemented, and I will just show you really quickly how this looks like in code so that you have a feeling about that. Let me just switch over to this one. So here we have now the classification prompt that we've just seen on the slide with the format that we expect, and we specify an own agent that is responsible for classifying incoming requests. And essentially this does nothing else than basically obtain the language model, get the system prompt, send a progress message to the user that we are doing now a classification. Then we take the conversation from the current chat session, put it into some format to represent the entire conversation as a basis for the classification, and then we send this to the LLM and request a certain response format. And then we essentially get we can parse this back then and give it as a result back. And the actual chat agent is the same as before, so that's the same system prompt as we had before. But before actually sending the request directly to the LLM, it first calls the classification agent, retrieves the classification, and then based on the classification retrieves the context, and that's here just super simple. So if it includes diagram, we obtain the diagram in a certain format. If it includes documentation, we include the documentation, and otherwise we just mock some code that we obtain from somewhere. Of course, in reality, this could be a code map where we look up things and stuff like that. Here it's just a mock. So that's the workflow agent 3 now. So let's see how this workflow agent 3 would now work. So we can now ask the workflow agent 3 what is the final task of this diagram, and you've seen there was a short progress message that it's now classifying our request, and now it can correctly answer that it's true. This is the last final task of the diagram, and that's because we determined that we need the diagram as a context, so we gave it to it, and that's fine. Therefore, we can answer this question. So let's try something different. We can now ask again, what does WT stand for? Again, we are classifying the result, and now it tells us that WT is the abbreviation for wait, and that's still correct because here we are still referring to wait in the documentation. And last but not least, let's try the code use case also real quick. We can, for instance, now ask which functions are called in check-TP, and now it will tell us, yeah, it's open can, enable LED and heat pump, and that's exactly, if you remember, what we just here always return statically for whatever you ask that is code related. So this is really then enabling you to dynamically pull in the right context for the right types of questions. And of course, this can be arbitrarily complex with different execution paths. Maybe you can even run that in parallel, invoking external services like language services for code or vector databases or whatnot. So this is really a typical technique applied here. Next, of course, we want to make the responses of an AI as actionable as possible. So not just showing text and giving suggestions, but really suggesting actions where the user can just, for instance, click a button to do something. And how this works is essentially we prompt again the LLM to provide certain types of responses in a certain syntax. Like here we use this XML-like elements to mark suggestions to create an element and give it a format, and then we ask, we prompt the LLM, if you're asked to create elements, generate a change command with the following syntax and so on. And then when we get this response for the LLM, the agent picks up this response, and before just showing it to the user, it will parse out these elements and render buttons instead. And how this works in Theia AI is that there is a contribution point where you can contribute dedicated implementations of response content matchers that will then be able to look at the LLM response first and match specific content types. And for instance, if we get this as a result, then it would first create markdown because that's what the default is. So we would render markdown. Then it identifies that there is a create element, so it will create a command part, then again markdown, and then again a command part, for instance. And then this is then handed over to the chat UI, and the chat UI invokes its response part renderers, which basically transfers this model here into the UI and the in terms of renderers, and the renderer for command would basically just create a button instead. Of course, we could also support links and stuff like that, where then the Theia open handler is invoked so that we can on-click open an editor or a file or something like that. So just how this would work in Theia AI again, we can now use this chat agent that is actually capable of parsing these elements to create new reasonable next steps. So as you see, it now renders buttons instead, and when I click those buttons, it would actually here create elements when I click it. Right. Good. Last technique that is commonly applied is tool calling. So the idea of tool calling is that you, instead of prompting the LLM to give you some responses, many LLMs provide the capability of registering tool functions, and then the LLM itself can decide whenever it wants to call these tool functions for whatever purpose. So these tool functions have a natural language description so that the LLM knows what they are about, and they have parameter descriptions to know to tell the LLM what parameters they require, and then essentially the LLM can invoke them. So the idea behind that is to put the LLM in a more agentic position, right? So because the LLM, you're not driving the LLM, asking it first to classify, then give you some response. Based on that, you give context and so on. But you just give the functions to the LLM and the user prompt, and the LLM itself decides when to call which functions. And that's a very common use case, actually, and very useful. for use cases like where the LLM, you want to equip the LLM with the capability of invoking actions in your tool autonomously, or you provide computations or functions to the LLM. So for instance, to validate the model, to compute whether nodes have an overlap, things that you can do very easily in your tool, but the LLM can't do it itself, or not as efficiently and deterministically at least. So you provide it as a function. It is also very commonly used to add context to LLMs, because you can essentially ask the LLM, whenever you need to know the diagram, just get it, here is the function, then you can call it. And that's really what is often very useful. This is also very easy to implement in Theia, because we have this concept of tool call handlers. So essentially how that would look like is, let me just bring it up here in the system prompt. You just mention all the tools that you want to make available to this chat agent, for instance, and then behind each of these tools there is a tool implementation, and this tool implementation essentially consists of the definition of the tool, like the description, the parameters this function, this tool function expects, and then a handler that is essentially executed. And I don't need to demo it to you, because that was the first demo that I showed, where I was just interacting with the tool. This was mainly based on just tool functions where the AI could then create nodes, trigger the documentation update and things like that. Of course, there is much more. We've just talked about only chat agents so far. You can integrate AI anywhere in your tool, and that's really something that is very, very useful. Because especially when you have custom editors, or you want to provide commands or menu items to trigger certain AI functionalities, that's very, very useful, because very typically from specific commands you can give very good context via parameters, via the special agent API, to give very concrete context and get very concrete and useful feedback. Very often you use structured output again to make processing the result of the LLM very simple, and typical use cases are auto-fixing issues, auto-completion in editors, or even multi-agent systems, which we've seen a little bit before, where one agent calls the classification agent, gets response back and stuff like that. And just to give you a very short demo how this would could look like. So let me just close that up and open this again, and we just delete that element. So now we have a validation error here, and we can right click it and say fix with AI, and then the AI will fix it for us. That's also just calling an agent from a menu item, providing this agent with the concrete context of this particular element and the validation error. And therefore the result is very reliable typically. So that was essentially the few features that I wanted to show. Just a few closing words. We really designed Theia AI to be as flexible as possible, and all the techniques that I've shown basically can also be combined for your use cases arbitrarily. So you can use chat and non-chat agent, combine them with variables and context augmentation, multi-term prompt flows, tool calling, content part rendering, and all of that. And the most important part is you have full control over everything, from the agent behavior to the tool data that you share with the LLM selection, whether it's on-prem, local, or whatever. And you have even full control over the UI and the chat UI. Just to give you a very stupid and funny demo, you can even change completely the UX of the chat. So for instance, if you now say, actually, I don't want this chat window anymore. We've already seen how AI should be integrated in tool. We can ask it to switch into the advanced AI mode. And now if I click it, then this is gone, and we get good old Clippy to help us out here, and we can ask it questions now instead. So you have full control. That's just a short demo to show you that you have full control over everything here. Right, there is many more features, from custom menus that you can add. You can observe the LLM output and agent logging, prompt editing prompts at runtime. So that's super useful during development, because it helps you a lot without rebuilding or anything, just changing the prompt and try it out. Observe the input and output of the agents and LLMs. great for debugging. And with that, I just want to close with a few recommendations. So first of all, I would really like to encourage you to start with your tool integration for your tool from the start, end to end. You should keep it simple at first. Start with basic prompt engineering and off-the-shelf language models, and add maybe basic context retrieval, function calling, multi-turns wherever necessary. But it's super crucial to start as early as possible, because this helps you to identify the required tool APIs very soon. This helps you to gain experience and learn which data you actually need. You can collect data from your users so that you can incrementally broaden and optimize your AI capabilities. This is not something that you can do from one day to the next. You have to really, for your specific use case, gain the experience and the learning to improve it into something production ready. Because as always with AI, it's easy to show one use case, one demo, but it's very hard to productize it. So you need then evaluation pipelines, good data to test, and stuff like that. Start early and gain that experience. And there is use cases that can already add value with very little effort from the start. And these are the use cases you should probably start with. With that, I would really like to invite you to start adding AI into your tools, and hopefully also Theia AI might be useful for you, especially if you have a Theia-based tool or are considering Theia as a platform for your tool, because this allows you to really focus on your domain-specific functionality and benefit and reuse from Theia capabilities and innovation without any additional effort. So visit us at eclipsesource.com if you want to talk. We are thrilled to support also you in your AI integration project with our services, from consulting, custom development, sponsored open source development support and training. So let's dive into your AI project. Looking forward to hear from you. Thank you very much.